So thank you very much for joining us today.
Steve, it's a real pleasure.
And I just want to speak on behalf of my colleagues in the college. Toyota is really a foundational relationship for us at all levels. We have obviously Toyota activity in the area here, TRI and Woven, and all the other activities. And so thank you for your continuing and steadfast support. And thanks for giving us the opportunity to ask you a few questions. Some of these questions talk about challenges and opportunities, but we really want to focus on some opportunities. As you know, there's emerging technology. We cannot have a fireside chat without talking about generative AI. It's just now part of the gig. This was not created with ChatGPT, I should say. What do you think are the new possibilities around mobility, and in particular with some of these new technologies like AI?
Well, I think generative AI, I heard it in almost every presentation I've been at here today, and I'm sure we'll get some more tomorrow. But more broadly, not just Toyota Research Institute, the whole automotive industry, there are four big opportunities now, kind of collectively known as CASE: connectivity, autonomy or assistance, shared, and electric. CASE. So connectivity makes it so that the driver is not just the operator of the car, but sort of the center of the universe, and they can be a shopper, a traveler, an explorer, and run a business, all kind of from the car. And the opportunities in e-commerce and blockchain are staggering. And when you count up the dollars, I bet you the connectivity that the cars provide now are going to turn all the time that you spend, that you're normally just listening to music or a podcast, into much more productive time. And that's going to have a gigantic effect on the economy. So autonomy, the self-driving, is another gigantic opportunity. The big savings or payoff for that, I think, is safety. And there are so many fatalities and around the world, and injuries that can be prevented by addressing driver distraction, road rage, all kinds of other things where your car does not stay on the road, your car does not stay out of contact with the other cars. So I think that's going to save many lives. So that's another huge opportunity. Sharing, ride share. That's kind of a little bit of a conundrum for the original equipment manufacturers, the OEMs, because it means that there's a need for fewer cars. And, they generate their revenues by sales. And, both the first new cars and used. They're gigantic markets. And the more ride sharing there is, especially with long-lasting cars like Toyotas, there are more Toyotas on the road now than any other brand. The more ride sharing, the fewer sales of both new and used cars. So it's both an opportunity and a challenge at the same time. And electrification, there are so many headlines now about battery electric vehicles. Kind of Tesla is leading the way there. It's another huge opportunity to reduce carbon emissions and to address some of the problems with sort of rare earth elements that need to go into the magnets that go into manufacturing and the drivetrains of the electric cars. So that again is another huge opportunity. So AI kind of fits in all of those areas, and so generative AI I think could be used in any one of those. That has a lot of opportunity, but to me, I see so many red flags. I've written one book. I asked ChatGPT, tell me about the books that Eric Krotkov has written. He wrote 3 books. And the one was real, and the 2 were plausible. Yes, I've done research in those areas, but there was no book, and there was nothing by that title. But it was so convincing and so real. I think that the biggest challenges that our community faces are in the responsible use of generative AI. There's still plenty of challenges in developing the technology, but the hardest challenges are going to be in using it and convincing everybody. It's like, whoa, take a chill pill. Don't just race into this and believe everything that comes out of Bard's or ChatGPT's mouth.
Just to echo that, I know that my colleagues here are on the front line this semester of dealing with this new technology. And like any tool, it can be misused or used for good. So it's like everything else engineers have always done. Just following up on the comments you made, some folks in the industry talk about becoming a mobility industry as opposed to a car and truck manufacturer. I know Toyota's also had vision about serving through robotics, other parts of the human experience. Can you comment a little bit about sort of Toyota's thinking about their future outlook of the company?
Yes, the past president of Toyota Motor Company, our grandparent, is Akio Toyoda, and he was famously talking about the need for Toyota to stop being a car company and start being a mobility company, and addressing all of the case opportunities and embracing them. And it's not just cars or trucks, but the whole mobility experience, and that includes micro-mobility, scooters. People are using those powered skateboards. I don't even know what to call them now. But people who need, who might be disabled or have some kind of a mobility disadvantage, things like prosthetics and orthotics to help people move. I believe that most of the other companies are also embracing that. And it's a fairly fundamental change. Instead of thinking about, there's our market, we want to meet these manufacturing or sales quotas, get to work. It's more like, well, what does our society really need? And those quotas came from a model of New York City or whatever city that no longer exists. It's, they're becoming smart cities and all interconnected, and thinking about how remote work ties into all of this. So there's sort of a virtual mobility as well as the physical, and it's all kind of blended. So there's some, I'd say, major shifts happening exactly to Toyota and its brothers and sisters in the automotive industry in thinking much bigger than just cars and trucks.
That resonates with us here. I think maybe you've seen our comments about people first engineering, and that sounds like a people first vision. So another question that we comment on is, many of us have interacted with industry, and we have contracts and we do our work, and sometimes it's transactional, but TRI's relationship with the partner universities is anything but that. It's actually really a deep relationship between your organization and Michigan and Stanford and MIT and the faculty, of course, who work in it. Can you talk a little bit about what motivates you to set up this relationship this particular way?
It's a great question, and I think it is something that differentiates Toyota, the Toyota Research Institute, from many of its peers. And Toyota has exceptional loyalty to its employees, its customers, and the broader society. I have been truly shocked by working for the fifth biggest company in the world, how sincere they are at the very highest levels about addressing social problems and trying to do what's right instead of what's profitable. And they're able to do both. But so the relationship is critical. And the way we have seen university partnerships go before is, okay, everybody, we're interested in problem X and its sub-problems. Send in your proposal. Oh, we like this one. Here's a check. Get busy, do what you said in your proposal, and send us the final report. And then you get it, and hopefully you can do something with it. And that just hasn't been that effective. So we have a very different model, and we have a TRI co-investigator. Dale, sitting at the front table, one of your fabulous alumni, is an example of one. And so there is no university partnership project that does not have a TRI co-investigator, somebody who is passionate. Yeah, I have to do this, and these university guys are going to help me. And if there's nobody on the team at TRI who's got that passion, we're not going to do the project. And so they then embed themselves with the team. They go to the biweekly lab meetings, and it's their reputation inside of TRI, and it's their name on the papers, it's their name on the patents that go in. So they are, it's not a transaction, it's their career. And then once I think the university partners get it, oh, he's serious or she's serious, we got to get serious too. And that works. So much more, the money is, I don't know, I think that there have been a number of projects where they say, you know what, I don't have any more students funded on this, but this guy has an NSF, this lady has a Hertz, and they're all working on the project because we want to work with you. So that kind of relationship is what has the spark that gets everyone excited, want to put in the extra effort to make the project succeed. And my job as head of the university program is not just, yep, that's a good idea. It's like, okay, does the co-investigator really have the fire in their belly to do this? Does it really fit with what their division is going to do in the next few years? And so I feel like the dating app. There's a lot more that goes into it, and what makes it special is not the technology, not the ideas. Those are necessary, but what is sufficient is the chemistry between the people.
It's a relationship, not a transaction. And to that point, I think that there's a sort of a pipeline of both talent and ideas that work its way through these relationships with TRI up through the company as you go. Can you give us some examples of where there's been some successes that you might want to tell?
Steve, you're so good at this. Have you ever done like a podcast or something? I think you'd be great at that.
The next job.
Well, let me describe the pipeline and then talk a little bit more about how TRI fits into it or manages it. TRI does applied research. Our outputs are papers, patents, and demonstrations showing that something is feasible that might not be so obviously feasible, which gives confidence for later stages. We have our partners that at the universities and national labs that do basic research, discovering principles and foundations. So TRI doesn't do that. And what's next in the pipeline is our venture fund. We have, we're trying to grow the community of people working on the areas that we care about by funding them. And so there's a $250 million frontier technology fund and a $100 million climate fund. And then the next stage in the pipeline is development. That is taking things that are known to be feasible and the demonstration that you did in applied research, well, you made it work once or twice. Now make it work in the snow, in the rain, with a cheaper processor, and prove it, mature it. And then finally there's production. So that's the whole pipeline. And TRI's overall goal is not just to help with cars. In fact, Toyota Motor Company does not need much help from anybody in designing, manufacturing, producing, selling, maintaining cars. They're looking to TRI to help develop ideas for and proofs of concept for new businesses for Toyota. Because with ride sharing, and I'm pretty sure that we're not going to be building a lot more roads. How many more cars can we really build and sustain on the planet? So what's Toyota going to do if it's going to be selling less cars? TRI, figure it out. And we rely on our university partners to help us with the understanding of what is possible. And then once we get the seeds of that, we will mature them a little bit in the TRI labs.
Very good. A lot of my research has been showing what's not possible, but that's been my problem going forward.
Well, that's very valuable.
That's right. That's right. We're about halfway through, and I thought we would take an opportunity to take some questions from y'all. We have the microphone here, and if anyone has a burning question they'd like to ask, raise your hand. Even non-burning questions are acceptable.
Hi, my name is Wes House. I'm an assistant professor in material science engineering. I have a few of colleagues in the past who have been funded by TRI to do what I would consider to be very basic beginning of the pipeline kind of materials discovery questions. And in material science, we usually think that by identifying material, there's still 18 years before maybe it even reaches the market. And I was always curious as to why TRI would fund this kind of very fundamental material discovery kind of work, given that it seems quite far away from deployment. And I was wondering if you could comment on that, and what kinds of research do you find to be interesting to fund in the material space?
Well, Toyota is incredibly patient and has a very long-term outlook. It does so well with cars and trucks that it can allocate some of its effort to really long-range things. Brian Story is the head of the Energy and Materials Group, and his OKRs, Objectives and Key Results, includes things that are due in 2050, which is a goal that Toyota has set for certain emissions standards. And he has a plan. It's much more detailed early, but he is targeting the growth of the technology towards that. So yes, TRI is quite different than many other groups, and the stability that comes from a socially aware and big, stable company allows them to take those long-term, they're kind of risky, but to aim at it repeatedly year after year. So hydrogen, is one of the fuel sources that no one is talking about. Toyota is almost alone in continuing to fund hydrogen-powered cars. They developed the Mirai, but there's no distribution channels for hydrogen except a few trucking places out in California. no matter. There's more patents and intellectual brain power going into that than almost anything else I know of at Toyota. So it really is a long-term commitment. So you also asked about sort of what is the energy and materials team doing in shorter term, and they're focusing on materials discovery and now a little bit materials design, both for batteries and for fuel cells. And one example is a search technique that looks for thermodynamically stable materials given, I forget the name of the database that they have, but so it's the AI of it has certain physical principles and thermodynamic principles, and it's using those to search. So it's burning up a lot of cloud time doing that. And they recently, they found lots of materials, and they say, well, let's try to realize this one. And it went to a lab at Northwestern, and they made it, they tested it, and it had all the properties that they predicted. That I don't expect they'll be able to keep that up for everything that they find computationally, they'll be able to realize physically. But that's an example of one of their thrusts right now.
You guys are in an interesting space. Like there's TRI, there's Honda research, there's Mitsubishi research, there's Tesla research, there's BDII is now gone into the game, and it's about Hyundai. And it seems like there's a lot of excitement and interest in robotics and AI, and it feels like there's almost like a competition towards something profitable, but no one's really being very clear and articulate about what that thing is. So do you feel like these companies, these research arms are in competition for something? Are they kind of trying to do the same thing? Are they their visions are quite different? How do you see TRI within the context of this new excitement in AI and robotics?
Thank you, Nima. It's certainly not set up as a competition. And I think Mark Raybert, the head of Boston Dynamics AI Institute, would say, yep, we're copying TRI. And a lot of the other places that you mentioned are funded by overseas companies, and a lot of them have gone out of business or gone into a team of 10 within 5 years. So TRI has been pretty different that way. Gil Pratt is our chief executive officer, and he is now the chief scientist for all of Toyota. And more and more people are playing senior roles and being listened to by big Toyota. And I don't see that happening at Mitsubishi Electric. I don't see it happening at Honda. I don't see it happening at Nissan. They're all doing good work. I'm not disrespecting or putting them down. AI is in many ways the Wild West right now, right? It's like land rush. Everybody, it's new, it's obviously got a lot of potential. Go out and find, get a stake, and then let's start panning for gold there. So in that way, it's a competition, but I don't think it's, I would say Hyundai also decided, yeah, Toyota's doing it, we're going to do it too. We'll see how long they all last.
Thanks for the question and answer. It was very informative. My name is Yiping Kang. I'm a research fellow from the Computer Science Engineering Department. At the beginning, you mentioned, right, vehicles are becoming smarter and smarter. Toyota are branching into more mobility than just vehicle. One thing that we can know for sure is across these devices, right, quote unquote, they're all getting smarter, right, with the help of AI. That's where it's going. But one of the challenge obviously is where the computation should live, right? Where the on-device kind of computation capability, what is enough to kind of continue this trend of advancement, and how does that interact with kind of what's available in the cloud? So can you speak to kind of in that area, what are some of the priorities, some of the focus that TRI has? Thank you.
That's a very perceptive, good question. When you go in your automated vehicle and do a data collect, you cannot upload the log file from all the Velodynes and cameras and IMUs. You have to go plug in, and it still takes hours to transfer everything. So first of all, TRI is not really active in that anymore. We graduated 150 of our researchers out of research into development. So they're now at Woven, Woven by Toyota, used to be called Woven Planet. And they're the ones doing development of the car. So I think they would answer, we need edge computing. And there's certainly, you can't do it all in the cloud. You certainly can't do it all on board. So we're going to have to make use of a lot of communications to access computing resources in a city, you know, block by block, in a rural area, you know, cell tower by cell tower. There's also, you know, some of these foundation type models, although they're gigantic, a lot of the executable part can be reduced dramatically in size and fit in a reasonable computer that you'd put in the trunk of your car. And the computation a lot of the vision, which I think is the power hungry and compute hungry stuff, can be done by specialized processors. So in the long run, I think a lot of it will be done on board, but never all of it. I think that's a fertile research area.
So I'll just add a comment on that. So when I was a youngling and computation was becoming a thing in mechanics, because there was such a constraint on the computational power, a lot of energy went into efficient algorithms, efficient architectures, because that's the only way you could do the problem. And then these young whippersnappers got a hold of the really big computers. It didn't really matter how they sort of chopped things up, they could get results. But I think we're now entering a period where, back to the future, you begin to have to really be more efficient and clever about how you perform your computation.
And do what's good enough, not what's perfect.
My name is John Piefer from Material Science and Engineering. So I have another materials question, and I feel compelled to extrapolate on some of the statements that you made about long-term vision and the decrease of number of cars on the roads. To what extent is the recycling or the end of life of a car and its components a concern for Toyota?
Great question. I don't know. I know there is a whole group, there's a new business unit that has sprung up at Toyota Motor North America, and recycling and refurbishing the metals and magnets is a big deal. And I don't know that they've put a lot of funding or effort behind it, but I think it's going to be increasing. And being able to not have some robotic work cell where you delicately assemble disassemble, and say, oh, here are the magnets. But to put them all in a giant bath of some kind, and then as things evaporate, to have it condense in a particular part of the workspace. So doing things in a bulk batch mode, I think would be a vision, and I don't think they have enough technology to do that yet. But I know that they have started a new business unit devoted to that. And can you imagine how many, if you looked at every junkyard in North America, how many batteries you would find? And you know, if you could melt them all down and get the nickel or cobalt or other materials out of it, and not have to get it from Zaire or other places, that would be a huge win. It would be a land rush for junkyards all of a sudden. So I think it has a tremendous potential.
Hey, thanks for this very information session. This is Rohini Balachandran. I'm from mechanical engineering. I have one more question on the energy and materials topic. You mentioned hydrogen. I'm very interested in hydrogen, both on the production side and also on its use for various processes, including CO2 capture. And I heard you mention about Toyota's interest in materials design and discovery. Is there also an emphasis on more systems level and process level innovations and experimental work involving hydrogen, which is still in the materials and energy space, or is this maybe totally out of scope?
Good question. The TRI is not doing much hydrogen work. There's a whole building when you go to the tech center in Toyota City, Aichi Province, Prefecture in Japan. You know, the headquarters building is like this, and there's two battery buildings right next to it, each quite a bit bigger. It's happening in one of those buildings, and not so much in TRI. I don't think they are publishing or talking too much about that work. It doesn't seem like many other companies are pursuing that research program, so they're kind of going it alone, and the need to sort of share information, it's like, well, nobody else wants to do this, we'll just do it ourselves. That's my best understanding right now. Brian Story would have probably a more thorough answer on that.
Hi, I'm Talia Moore. I'm in robotics, mechanical engineering, and ecology and evolutionary biology. And so, given the kind of competition, the lots of companies in the kind of robotics and AI area that Eva mentioned, I kind of have a question about the priorities of TRI. So, would you say that the priorities are sort of in common with what everyone else is working on? Are there maybe more specific hard problems that TRI is like focused on? Or instead, are you more interested in like surveying the proposals as sort of like an incubator for new ideas of, oh, that's kind of interesting, no one's ever thought of that, I've never heard of it, and let's try it out?
Thank you for that question. The way we pick the kind of research thrusts is pretty top down. And the robotics efforts have been inspired by and pointed at aging society as, you know, a huge social trend and problem, and also a big opportunity to make a difference. So Japan is feeling the aging society quite acutely now. I think China is not far behind, especially because of the coming of age of the one-child population. And so there are just not enough younger people to take care of the older people. And that's going to be rippling through in the West as well soon. So we kind of start with that. So what are some of the main things you need for that? And manipulation was the answer. So let's do a lot of manipulation research. The energy and materials, there's a, you know, extremely exciting, lots of great work to do, but if it's not ultimately reducing carbon, it's like, that is the calling. Let's get our emissions down. That is what is inspiring it all. So it's not what's cool, or there's a top-down part, which is if it's not contributing to that social need, you can't make some good argument about that, then we're not going to do it at TRI. But then more of the bottom up, you know, there's lots of ways you can do manipulation. And there it is more of a free-for-all. And it's whatever people like Dale, our co-investigators, are excited about, not what TMC headquarters or Toyota family thinks. Did that answer?
Yes.
Thank you.
So let's thank Eric. I just want to say before we go that long time ago, this country had something called Bell Labs. And one of the hallmarks of Bell Labs was patience and allowing creativity to flourish and the commitment to the long-term idea of research. And it's nice to know that there are still some institutions who honor those traditions and actualize them, and our partners at Michigan. So once again, I want to thank Eric for his time today and for his partnership. Thank you.